Welcome back, everyone. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, broadcasting live Apple Valley, California.
Science and technology is what we talk about here.
The People's Republic of California. It's just sickening all the stuff we hear about California.
Newsom gets to raise our electric rates. How about that, huh?
Okay, brighter news. The helicity barrier, and helicity sounds just as nefarious as it is, um, because if you think of hell, fire, and brimstone, that's what we're talking about, has been directly confirmed, offering new insights into the heating and formation of the solar wind. Scientists have long been puzzled by an unusual solar mystery. The sun's outer atmosphere, called the corona, is vastly hotter than the surface below it. Adding to the intrigue, the solar wind, a continuous stream of charged particles and magnetic fields flowing out from the sun, reaches extraordinary speeds as it moves into space. This research was published on July 8th, 2025 in Physical Review X. Would you like to know more?
A process called turbulent dissipation, where mechanical energy is converted into heat, is thought to be central to both of these effects. However, near the sun, the environment becomes nearly collisionless, making it difficult to understand exactly how this energy transfer occurs.
Huh. To investigate this mystery, researchers turned to data from NASA's Parker Solar Probe, which now holds the record for the closest approach to the sun by any spacecraft. I wonder if they have shields, like in Star Wars, Star Trek, I mean.
Gotta have something, right?
By passing directly through the solar atmosphere, the probe has offered scientists an unprecedented look at the conditions surrounding our star, enabling direct examination of regions previously out of reach.
The findings from this study offer strong evidence for a previously proposed phenomenon known as the helicity barrier. This effect significantly changes how energy from turbulence is dissipated. Specifically, the helicity barrier interferes with the energy transfer at small scales, altering how fluctuations break down and how the surrounding plasma is ultimately heated.
Jack McIntyre, a PhD student and the lead author of the study from Queen Mary University of London, commented, quote, "This result is exciting because by confirming the presence of the helicity barrier, we can account for properties of the solar wind that were previously unexplained, including that its protons are typically hotter than its electrons. By improving our understanding of turbulent dissipation, it could also have important applications for other systems in astrophysics." End quote.
The research team also identified the specific conditions under which this barrier occurs. They found that the helicity barrier becomes fully developed when the magnetic field strength becomes large compared to the pressure in the plasma and becomes increasingly prominent when the imbalance between the oppositely propagating plasma waves that make up the turbulence is greater. Critically, these conditions are frequently met in the solar wind close to the sun, where Parker's solar probe is now exploring, meaning that this effect could be widespread.
Now, if you thought that what Scott said was, I
I didn't think. I know.
I tried looking up helicity barrier, and I came up with helicity, and the physics is just I couldn't understand it. I've taken some physics courses in college, and this stuff was crazy.
I went out with a girl in high school. I think her name was Helicity.
Oh
So
yeah,
I think so.
Doctor
Sounded like it anyway.
Helicity.
I,
Dr. Christopher Chen. These gnats are crazy, man. Dr. Christopher Chen, reader in space plasma physics at Queen Mary University of London and McIntyre's supervisor, added, quote, "This paper is important as it provides clear evidence for the presence of the helicity barrier, which answers some long-standing questions." That's about what the other guy said. Which answers long-standing questions about coronal heating and solar wind acceleration, such as the temperature signatures seen in the solar atmosphere and the variability of different solar wind streams. This allows us to better understand the fundamental physics of turbulent dissipation, the connection between small-scale physics and the global properties of the heliosphere, and make better predictions for space weather.
Okay. The implications of this discovery extend beyond our own star, as many hot, diffuse astrophysical plasmas in the universe are also collisionless. Understanding how energy dissipates into heat in these environments has brought broad consequences for astrophysics. The direct observation of the helicity barrier in the solar wind provides a unique natural laboratory to study these complex processes.
We'll take their word for it.
I
Yeah.
definitely will, because I have no idea what we just talked about.
But maybe there's some physics dudes that or girls, chicks that are watching this
Yeah.
from our viewers that know what we're talking about.
Yeah. Let us know if you know what we're talking about.
But
So,
just that it's the closest one that's approached the sun so far. That's cool.
yeah.
I think we should take all of our nuclear waste, just put it in a rocket, and boom, shoot it at the sun, directly into the sun.
You don't think that might have some kind of negative impact, though,
No,
on the
like
sun and
uranium.
or the solar system?
No, just a little tiny compared to the sun. That's not gonna. No, it'll
Okay.
burn up before it even gets to the corona.
Okay. Give it a shot.
All right, folks. Thanks for joining us. We'll talk to you later.
Take care, everyone. Thank you. Have a good day.